Hey guys, what's up? Welcome to this video about the React profiler. So right here I grabbed a small statement from the React docs that essentially tells what the React profiler actually is. So let's take a look. So it says the profiler measures how often a React application renders and what the cost of the rendering is. Its purpose is to help identify parts of an application that are slow and may benefit from optimizations such as memoization, which we have talked about before in the previous video. So to get started with the React profiler, you will need the React DevTools extension, which you can simply find for Chrome. But if you have been following the course, you already have it installed. And that will, well, essentially allow you to use the React profiler. In this video, we are also going to use a library called Why Did You Render by Well Done Software. Honestly, that's a great library. It works very well together with the profiler, as you will see later on in the video. So let's get actually started. First of all, we need like a real world application, right? Because we need to have at least something to analyze, and you know, the bigger the app is, the better, because most of the times, you know, big apps will at least have some well, you could say either performance problems or could have, you know, potential performance improvements. So we are going to use the Cypress real world app. By the way, this has nothing to do with with testing or whatsoever, but this just is an application that was created by the Cypress team. And of course there is like your Cypress test, but this is more like a demo app where they show how you could test a real world application. But having that said, we're going to use this app for another purpose, and that's actually to run the profiler. So first of all, we need to clone this project. And well, as you can see, I can clone it right here by copying the HTTPS, and I can just say git clone and press enter, and we'll be cloning the app. Now, if you're watching this video because you see this app is frequently updated, you know, the last commit was 10 days ago, it might be you have like a complete different app. So we are going to use this commit, which is the most actual or current commit as of now. So I will also put that link down in the description, which is this link, and you will need this commit ID to make sure you're on the right, you know, have the same state of the application as I will have in this part of the video. So we can actually cd into the Cypress app. I will just restart my code editor in that specific folder. So as you can see right now, we have the code from that project. And what I then want you to do is to say git checkout, and you know, grab that ID from here, paste it, press enter, and now you're on the same commit as I am. For me, it doesn't make a lot of difference, or actually no difference, because the current branch is actually this commit, but you know, we'll just leave it for now. And then we want to install Why Did You Render, and we also need to configure it. So I'll also put a link down below to this GitHub repository. So as you can see in this project, they are using Yarn. As you can see right here in Cypress. I'm gonna scroll down. Oh, wait a second. I need to click the project itself. There we go, Cypress real world application. So you see they're using Yarn. Before we've been using NPM. Sometimes, you know, you can just use both of them, but I run into some problems using NPM. So we're just going to stick with Yarn. So instead of saying NPM install, we're going to do yarn add, and we will add that package as a dev dependency. So I will actually just put that right here. All right, so we can already start configuring the this library, so the why.render library. So first of all, it says that we need to create a why.render.js file and import it as the first import in our application. So I will go to the source folder. So right here where we have index, and then I will create a new file and I will call it why did you render. But this project is using TypeScript, so instead of JS I will do TS. So I will copy this snippet from the docs, and now you see that if we're using TypeScript, we can add the this line on top of the file to import the package types. We will not be using it in this video, but I think it's a good practice anyway. If you would like to well, as you can see there, there's a lot more you can configure. But for now, I'll just save this. All right, so we got why.render installed, or not installed yet. It's still going, but we got it configured. So I will get back to you once it's installed. Why are you lying, man? Because we did not configure it properly. This is Mitchell from the future, and we actually have to add this line right here to our index.js file, or because this is a TypeScript project, will probably be called index.tsx, this one right here in source. So we're going to add this line and add it on the top right here. So if you've done that, you're good to go to watch the rest of the video. All right, so now it's installed, and we can actually start the dev server with the command yarn dev. So we're going to use that. That also will take some time, so I will get back to you once that's done. Yes, so I'm back. As you can see, the app automatically opened in my browser, and something I'd like to clarify, because I didn't say that before, but the reason I'd like to show you this with a real world app is not because we need it, because you know, I can also make an application myself and show you some examples, but I think this is just a very nice way of seeing how we can use the profiler in like a real world use case. So the first thing I want to do is log out, and now it prompts us to sign in. Now if we go right here and I will search for users, you'll see that we can log in the app with any of the example app users. So I will go for Tavares Barrows, and you see the password is secret with a 3. So that's like this, secret. So paste that in there, remember me, sign in. All right, so this is the demo application. So you can see we have a sidebar menu with some options. It's like a banking application, so we can see transactions of friends or our own transactions. We can like transactions. We can even add a comment. We can make new payments. We can search for folks. We can add notes, and then you'll probably, we go back to the transactions, you will see that the Apple's transaction was made. So you yeah, it's kind of like a banking application, but everything is run locally. So also there's no real API calls you're making, because they're all you know, done in a local environment. So you're not really sending a request to a server, or like a real server or a database. But having that said, let's take a look at how we can use the profiler. So before we do that, I'd like to talk about how we should use the profiler properly. What we want to do is we want to mimic a real world scenario, and this, because we just ran yarn dev, and that means that we are currently running this app in a development build, right? So that's an application, pretty much the app optimized for developers. But As you will see in the deployment section of this course, you can also make an optimized production build. And that's actually the product you want to ship to your customers, right? So that's the one people will actually use. So that's why you want to usually do your profiling with the production build, and you can simply do the production or create one with the profiler, because by default the profiler is disabled because it could interfere with the performance of your application. So you could run the command. If you're using npm, of course you can use npm like you can see right here, but you would say yarn build -- profile, and then if you press enter, then it will create a production build, and that's actually the one you want to start profiling. Now in this video I will not do that, simply because we are going to make some changes to the code, and I want to check those changes immediately without every time having to rebuild the application. But usually speaking, you want to do this with a production build. The other thing we want to do is we want to throttle our network and CPU, and we can simply do that by going to the Chrome DevTools and select low-end mobile. So if we go right here to the app, and I will open up my DevTools, and I click right here on this icon, the toggle device toolbar icon, you will see that right here you see no throttling. When I click it, I can select low-end mobile, and when I click it, you will see that right here in the network and performance tab you get this warning sign, and now you will see that we throttled our network to like mimic a slow 3G connection instead of fast 3G or no throttling. And when I go to performance and click right here on this settings icon, you will see that we have, well, currently the slow 3G network, but also our CPU is slowed down. So it's well, it appears to be has a 6 times slowdown. So we throttle our CPU so it's not as fast as our at least the device I'm using right now, because you have to imagine maybe you're working on a MacBook Pro, right? Or some other kind of PC that's pretty fast, or even a phone with good specs. But there's also people that will visit your application or your site, and they might, I don't know, they might be using like a Moto G4 or like an iPhone 5, with some outdated tech. So those devices are slower. So that's why we want to throttle the network and the CPU to kind of like mimic a user with a slow device, so we can really get the best results up for in the worst case scenario, so to speak. The next thing I'd like to ask you is to enable a setting in the profiling tool. So if you have the React DevTools installed, you can click right here on Profiler, and when you click right here in the settings icon, you can see I already have it enabled, but you can select record while each component rendered while profiling. So I recommend you to turn that on. So let's actually start using the profiler. So I will actually go back to a home, right? So our home screen right here, and I will click on this reload icon, which will reload the application, and you will see it will be very slow because we throttled the CPU, and it will start the profiling. So click it, and now you see that our app is reloading, and you'll see that this takes like a serious amount of time. So whenever you think your React app is fast, just try to throttle your CPU down, and you'll see how slow it could be on slow devices. So now you see some things are loading up. Now we get the transactions. We'll be waiting for the avatars to. There we go. All right. So it seems like our app has successfully loaded right now. I will click here to stop the profiling, and I will actually make the screen a little larger so you can see what's going on. So it might look a little overwhelming, but we will just go through the profiler results step by step. So I'd like to bring your attention to this right upper part of the profiler section. And you can see that we have 21 commits, right? So these are all the commits that were being made. And whenever I click on a commit, you will see when it committed and what the render duration was. So you can see that these, the initial commit took about 2,000 milliseconds, which is about 2 seconds. This one took about like over half a second, also about half a second, so these definitely took a little more time. But these ones are, they're very, very, very small. They are like 2 milliseconds. So, especially if you have like a lot of commits, in this case, I'm not really concerned about, let's say, everything below a commit that takes about 17 milliseconds. So I could, for example, say hide commits below 17 milliseconds, and now we get like the commits that were a little bit more costly. So we want to focus on the orange or even reddish looking commits. Now you see we don't have any red commits, but this one is definitely orange, and you see the longer it takes, the more orange it will look. So yeah, so what we're actually going to do is we're going to try to identify if there are, might be some performance issues. You got to keep in mind that whenever you're using the profiler, you should probably have a valid reason for it, right? So maybe you or your colleagues or, the users of your application are experiencing some performance problems on, let's say, the home page. So in that case, I would, start and actually do the profiling session to see what's going on here. But otherwise, don't be too concerned with what we're going to do right now, because you will see it takes quite a bit of time. But what I'm going to do, I'm going to analyze the profiler results. So I can tell you straight away that when I click this commit right here, you will see a flame graph, and you'll see that right here we have a router and some context providers and some app, and then down below here we have like all kinds of components and even other contacts. So this is essentially a flame graph of all the components and contacts that rendered in our application. Most of the time I find myself looking at this one, the rank chart, because it sorts everything from top to bottom, which took like the most time to render. Now, the initial commit often takes a little bit of time for applications to render, because as you can see right here, app is like, that seems to be definitely the most problematic render in this commit. But when I go back to the code and I will check out our app .tsx file right here, when I scroll down, you will see that we've got an error right here. Okay, well, that's not much of a problem for now. So it seems that it uses the use machine, and it uses use service, which is like an auth service. So right here, it's determining whether the user is logged in or not, and is returning things based on that, and that could definitely take a bit of time. So I'm not too much concerned with that initial load, because generally speaking, for React apps, the initial load, takes quite a bit of time anyway, because it's a single page application, or at least if you're using it in the way we've done before during the course. So I'll actually focus on these other commits. So let's take a look right here and take a look at the components or contexts that are rendering. So I can see read styles, but that seems to be memoized already. Then it will have that memo keyword in there. So I'm not too concerned about that. Here we see grid component. That definitely seems to take quite a bit of time. Transaction amount. Here we get transaction item. Also here we can see grid. Takes quite a bit of time. Here we have grid again. So also transaction item. We've got nav drawer again, grid. So it seems, what I'm looking at is how often do I see certain components pop like at the top of those commits. And what comes pretty apparent to me is that that grid component is definitely, coming along in a lot of those commits. So when I click right here on the grid itself, you will see why it rendered. So for this, well, at least at this render, it says this was the first time the component rendered. So, fair enough, that every component needs to render at least once. And then when I scroll through here, you will see all the commits where the grid component rendered as well, or actually re-rendered. And then you see these all rendered because the props changed, and the prop that actually changed, or at least caused the grid component to re-render, was the row re-render property. You can see it takes quite a bit of time, right? Like almost every time it takes about half a second. So let's take a look at that, that grid component to see if we are able to optimize it. So the reason I asked you to install Why Did You Render is for a reason, because if you go to your console now, you will see that we get some console logs from the Why Did You Render library. And you can see right here the components it's targeting, and you can see that it also detects that that grid component rendered a couple of times while it was not necessary. You can see right here the message says re-rendered because of props changes, and here you can see that props row re-rendered just like we saw in the profiler. And right here it says different functions with the same name, and right here you see it does a comparison between the previous function and the next function, which appears to be called row re-render. And then right here you can have a link and you can find more about that that message. So this is actually by Vitaly Zeitman. This is the core maintainer of this library, and here he has a lot of like error or messages that pop up and what they actually mean. Now, unfortunately, you can't find anything about different functions, but it comes down to the same thing as different props, right? Just like it said right here, re-rendered because of prop changes. And what I'd like to draw your attention to is this right here. It says, because the props object is always new for each re-render of a child, right? Well, you can see it right here. He says, always remember that JSX prop A syntax is just sugar for React create element JSX prop A. This means whenever its father re-renders, JSX tries to update itself with a new props object. And that's exactly what has happened right here. So the row re-render is a function, but as soon as the parent component re-renders, well, essentially the component that defines that row re-render function, it will pass down the row re-render as a new property. So they will not be equal to each other. So that's why React will re-render those or that grid component. Well, that was not necessary because essentially the function stayed the same. So let's try to identify where this row re-render lives. Well, we could essentially go to the profiler. Of course, we could search our code base, but I'd like to show you where this is coming from. So when I click on grid and I click on flame graph and I scroll all the way down, you will see that grid appears to be rendered by list, and that one seems to be rendered by infinite loader. And then right there we got a component called transaction infinite list. And I know this for a reason, because if I will be searching my code base, for example, for grid, I will not find it. I will also not find a component called list, but I will be able to find transaction infinite list. And what you see right there is that row re-render function we talked about before, which is this one. You can see that this row re-render is being passed down to this list component as a prop, and then that list component appears to be part of React Virtualize, which is another library. So we definitely don't want to make any changes in here, but this is where also that grid component is being used. So what I will be doing, I will memoize this row re-render function so that even though when this transaction infinite list component re-renders, the row re-render function will be memoized. Thus, it will not create or initiate the grid component to re-render and thus cause like a potential performance problem. So I will say right up here, I can say const row re-render, and I will say use callback. This is a hook from React. And before we actually continue this, I'd like to show you this. So there is 3 ways you can memoize out of the box with just React, and that's either with React.memo, which I will show you in the last part of this video, and use callback, and also use memo, which we will not be using in this video. But think about that whenever you want to memoize a component with props, you're looking for React.memo. If you want to memoize a function like what we're trying to do right now, we can use callback, and for values we can use memo. With having that said, let's actually go back to the code. So right here we have use callback, and it needs a dependency array. And in here we can actually just put the function. And now when I save it, you will see we get a not an error but a warning. You see that the React hook use callback is missing dependency, so it just says with use effect, right? We can simply let them be updated automatically. So you can see when I hover over use callback, it says use callback will return a memoized version of the callback that only changes if one of the inputs has changed. So that means that when, for example, either key or index or style changes, then of course we want that row re-render function to change. But if those are, those props are staying the same, we just let it be as is, and we do not create a new function. And I can actually even clean this up by removing this. And then I have to do like this, like an arrow function. Okay. So now when I save it and I go back to my app, go to the profiler, and just keep this in mind, right? So we have our grid component that seems to render, well, it rendered like 4 times, it re-rendered 4 times. Of course, we had the initial render, and then it had like 4 like wasted re-renders, so to speak, right? So they didn't make a lot of sense, as was also suggested by the why did you render library. So let's rerun, reload our application and start profiling again, and take a look at the results. So this of course will take some time. And what you see is that it takes quite a bit of time to, identify those problems and to actually solve them. So I recommend you to not overdo this. Just, as soon as you're experiencing performance problems, then you of course can look into it, but don't stress too much about it. So now we will wait for the app to finish loading. I think that's about right now. So we'll stop profiling. And now you will see that whenever I, let's take a look. Let's go to ranked. Now you see we've got the grid component. But now you see it did render once, and it took quite a bit of time, but there's probably some heavy calculations maybe going on. So I'm not too worried about that. But you see, by using use callback, we prevented those 4 wasted or like unnecessary re-renders. So that's a example of use callback. So the next and last thing I'd like to show you is React.memo. So I have been taking a look at this app, but I haven't really found any problems really. So we're just going to create our own problem, or at least show you what I mean. So we want to go to our app.tsx file. All right, and I'll just make a couple of components down here just for demonstration purposes. So let's say we have a parent component, right? So let's say function parent component, which returns two child components. I'll actually copy this, and I will say child component A. For now, it will return child A, and we will also have a component child B, like so. And then this parent component is going to re-render or is going to render that both of those child components. So we will have child component, child component A, and we have child component B. And now both are being used, but we also need to render the parent component now in our app. So as you can see, when we're logged in, it renders that private routes container. So just below there, I will render that parent component. And I'm sorry about the error going on right here, but it's not really a benefit to solving it right now. All right, so we added the parent component. So now when I save this and I go back to our app, and I'll just for now go back to no throttling, so our app is loads a little faster. Then right here you see there's like a small gap, and when I actually remove that header component, let's see, it seems to be this one. Yeah, when I delete it, you will see right here child A, child B rendered. So they are now being rendered on the page, but that doesn't really matter that much. What I want to show you is how this, how we could prevent like a unnecessary re-render with React.memo. So let's imagine we have some value defined right here. For now, we'll say useless value, and this will then be set useless value is use state, and we set it to 0. And let's say only child component A is using that value, and child component A also contains a button that increases that count. So I will also pass the set useless value, and then right here in child component A, we have to destructure those props. And now I can say, instead of just returning child A, we can also return, let's say, a button that has a type of button, and let's click me or increase count, and then we can say on click, it will actually set the useless value, and it will take in the previous state, and it will then return, man, I felt like too many typos, previous state plus 1. Okay, so I'll save this, and of course right here, because we're using TypeScript, usually we would of course create some some props interface for this, but for now I'll just leave it, or called any. Pref state has any. Let's give that any as well. Of course, it's very bad practice. Don't do this in production or in like a real life situation, but for now this is okay. Oh yeah, and of course we could say that this says instead of child A, it also renders the value like that. Okay. So what I will do now, I will ensure that a console log is being made whenever component A and B are being rendered. So here I will say console log child A rendered, and right here I will say child B rendered, like that. Now when I go back to the application, you will see that, and I will just reload the app. You will see that it renders 3 times. That's because our app is rendering again, because probably I'm not completely sure about that, but probably the auth state was set or something like that. But now whenever I would just clear the console, whenever I click that increase count button, you will see that both child A and child B render, right? You'll see with every click, both of the components are rendering. And you can ask yourself, why do we even want to have child component B being rendered if, you know, nothing changed, right? It doesn't even receive any props. It just displays child B. So why should it even re-render? And well, that's a good question. And you know, there are cases where this could lead to performance problems. So in those cases, you can use React.memo, which is pretty simple. We can say const child component B, as it's very similar actually to the use callback we used before. And we can say React.memo. And in here, we're going to put our function. And now when we save it, you will also see that whenever I go to components and I will search for the child component right here, you will see that now the child component B gets like this memo, you know, icon behind it. But you will see that now when I refresh the page, initially it only renders our child component B once, and whenever I click the increase count button, it will only render component A, and component B will just stay as is because we have memoized it and nothing changed. So you know, that's a potential performance benefit you get from there. But I think most of the time you can get most bang for your buck if you're, you know, trying to solve performance problems. But of course, first taking a look at you know, what's actually causing, because, you know, often if an app feels like laggy or slow, you know, sometimes it could also be network requests that just take, you know, quite a lot of time. So of course, don't forget to, you know, about those things. Or maybe you're, you know, like we talked about before in the previous video, like you could potentially have made some wrong decisions regarding state management. But of course, you can use this for you know, as memoization to solve these kind of problems. But I think you can get most bang for your buck if you're focused on the console logs you're getting from why did you render. You know, it's very easy, and you don't have to do a lot with the profiler, right? Because everything is being console logged. Now, what I would like to emphasize, though, is that you want to remove that why did you render file in production, right? And I think by default right here it uses process.env.node, so it will check if it's in development, and only then it will enable it. But make sure that you do not run this in production, because that could in and of itself give you some performance problems. So yeah, that was pretty much it for using the profiler. I think that the main takeaway from this video is that you know, that profiler is a nice tool to identify some performance problems, but it can just be, pretty difficult to actually identify what the problems actually are. And as you can see, it can definitely take quite a bit of time. So spend your time wisely. There's a lot of other things you can do to improve the performance, or like the let's say the speed of your application. Think about React Query, that's the data caching. So that can also give your users a lot, much better and faster experience. So having that said, thanks for watching, and I'd like to see you in the next one.